number 17, we have degree 3, so that means we have 3 possible zeros, and we're given 2 of them. One of them is 1, and the other one is negative 2 minus I. So when you see that imaginary number, note that you're going to have the complex conjugate, or the opposite of this. So the missing 0 in this term is just negative 2 plus I. So if you just remember, whenever you have imaginary terms and you change that sign in front of the imaginary term, you will also have that as a 0. So that's given from definition or knowledge of imaginaries. All right, so 18, we want to decide if this statement is true or false. Given the graph of this, it says it opens up, and we do know that that will be true because the leading term is positive, so it should be opening up. So the fact that they say it opens up, that is a true statement. All right, number 19, we're going to answer parts A through C, and I think this one is just what it is. No, so A has several parts, okay, so as you can see, it's not just one part. So we're given a quadratic function, and we want to know if it opens up or down. Okay, so the leading term is positive, so that tells me it opens up. All right, now we want to know the coordinates of the vertex. So since this is not in standard form, since it's not in vertex form, we actually have to work out the vertex. So it's in standard form, ax squared plus bx plus c. So the way you find the vertex, you can do negative b over 2a, and then the y-coordinate would be 4ac minus b squared all over 4a. So you got to remember those. You should have those written down somewhere. This time I'm going to do just a little bit different, but use a method that you're familiar with. I'm going to take this value and plug it in, but I'm going to do synthetic division. So our parabola is x squared minus 2x. So whenever I find negative b, that would be a negative into a negative, so it would be a positive 2. So the x-coordinate is positive 2 divided by 2a. That would be 2 times 1. 2 times 1 is 2, so this just gives you 1. So the x-coordinate is a 1. So part of your vertex is 1. All right, if I take that 1 and just plug it in here, okay, it's really easy to do that because it's a small number. Sometimes it's not, so using that might be helpful. But if we plug in 1, that will give me 1 squared minus 2 times 1. It's not too bad to do that as compared to that. So this is 1, and then this is 2, 1 minus 2, negative 1. So you get a negative 1. Now you can plug it in here. It's totally fine. But you also have the option to plug it in. I said I was going to do synthetic, but since it was a small, it was easier just to plug it in. So we get our vertex 1, negative 1. And this is the way that I'm more familiar with doing it anyway. Find the x value and then plug it in. So the axis of symmetry just matches the x coordinate. You have to write an equation, so you need to write it x equals. So we're doing x equals 1. It's just the line where x is 1. It's an imaginary line that will cut right down the middle of your parabola. The x-intercepts. So when we find intercepts, we're going to let y equal 0. So I'm going to say x squared minus 2x equals 0. We can factor this by pulling out an x, and that will leave us with x minus 2 equals 0. And when we set both of these equal to 0, we get x equals 0 and x equals 2. So these will be your two x-intercepts. And it says type an integer or decimal, so we don't have to put it in ordered pair form. All right, the y-intercept, so if you would just plug in a 0 for the x's, you would get 0. So the y-intercept is 0. We don't have a y-intercept. So just remember, familiar thing we've done, just plug in zeros. So what I'm saying is y equals, you would plug a 0 for x squared minus 2 times 0. And all of this would just give you y equals 0. So that's how you get your y-intercept of 0. Okay, so I think all of this is still part A. Okay, so we're done with part A now. We're going to graph it. So this is a parabola. I would start out with the vertex that we found. So I would go right one for the x-coordinate and down one. It's very sensitive. So that's one ordered pair. And then you can plot either y-intercept or x-intercept. So let's go to 0, 0, because that is an x-intercept and a y-intercept. So from there we can save it, and then that's our parabola. If I was to draw a line right at x equals 1, it would cut it right in half. That's the axis of symmetry. All right, the domain is all real. We don't have any fractions, square roots, or logarithms. So we're going to say from negative infinity to positive infinity. And then the range, this parabola, the lowest point we hit in the y direction is -1, and we do actually reach -1. So we're going to put that in a bracket, -1. And then it goes all the way up to positive infinity. So being able to see your parabola, or at least compute the vertex, is what you need to be able to find the range. If you know it's opening up, it goes to positive infinity. If you know it's opening down, and this term was negative, it would be from negative infinity up to that high point. All right, so now we want to determine where the function is increasing or decreasing. So increasing first. You always denote it by the x-axis. So going up, this graph is going up, starting when x equals 1 all the way to positive infinity. Okay, so that's how we denote it. You never put brackets on increasing, decreasing. So we're going to say from 1 to infinity, this graph is increasing. Again, that is saying it's going up from left to right, starting at this number 1 in the x-axis, going all the way to the positive infinity side. All right, it is decreasing, going down from left to right on the negative infinity side, and it's decreasing the whole time until we get to that same point 1. So we're going to say decreasing from negative infinity until we get to 1. Now don't put -1. I know it might be, you want to say from, if you're thinking about the y direction, you might want to say positive infinity until we get to -1, but that is the common mistake that people make. You want to restrict your eyes to the x-axis to describe where that increasing and decreasing is happening.